Hello everyone. Today we are going to see different terms which are included in the structural analysis. First one is Poisson's ratio. Poisson's ratio, it is denoted by the sign mu. It is the ratio of lateral strain to the longitudinal strain. Poisson's ratio for the different materials is as follows. For cork, Poisson's ratio is 0. For steel, it is 0.27 to 0.3. For concrete, it is 0.1 to 0.2. And for perfectly elastic rubber, it is 0.5. Then we are going to see different types of the structure. First one is trusses. A truss is constructed from pin-jointed slender members which are usually arranged in the triangular manner. In trusses, the loads are applied on the joints due to which each member of the truss is subjected to only the axial forces. That means either axial compression or axial tension. Generally, trusses are used when the span of the structure is large. The next type of structure is frames. A frame is constructed from either pin-jointed or fixed-jointed beams and columns. Generally, the loads are applied on the beams and this loading causes the axial force, shear force, and bending to the members of the frames. Then third type of structure is arches. Arches are used in bridges, dome roof, auditorium, where the span of the structures are relatively more due to the external loading. Arch can be subjected to axial compression, shear force, or the bending moment. Then fourth type of structure is cable. Cables are used to support the long span bridges. Cables are flexible members and due to the external loading, it is subjected to axial tension only. Then we are going to see different elements which are used in the structure. First one is beams. Beams are the structural members which is predominantly subjected to bending. On the basis of support system, beams can be classified as the simply supported beam, cantilever beam, propped cantilever beam, fixed beam, and continuous beam. Then second element of the structure is columns. The column is a vertical compression member which is slender and straight. Generally, columns are subjected to the axial compression and bending moment. Then next element of the structure is tie members. The tie members are the tension member of trusses and the frames which are subjected to axial tensile force. After that, we are going to see the different support systems. The first one is fixed support. In case of fixed support, there are three reactions. First one is a vertical reaction. That means the reaction which is perpendicular to the member. Then horizontal reaction. That means the reaction which is along the member. And third one is the moment reaction. Then second type of support is hinge support. In case of hinge support, there are two reactions. The first one is horizontal reaction, which is along the member, and Second one is the vertical reaction, which is perpendicular to the member. Then third type of the support is roller support. In case of roller support, there is only one reaction acting on the member, which is vertical reaction. That means perpendicular to the surface of the member. Then fourth type of the support is guided roller support. In case of guided roller support, there are two reactions. First one is the vertical reaction and second one is the moment reaction. The next type is internal hinge. In case of internal hinge, the bending moment is zero at that point. Here the point C is located as internal hinge, so bending moment at the point C is zero. The next one is internal roller. At internal roller, either axially force or shear force will be zero. After the internal hinge, the next type of support is internal roller. At internal roller, either axial force is zero or the shear force will be zero. Here, in this case, the axial force at C and D is zero, while in the second case, the shear force at C and D is zero. Then next type of the support is internal link. If any member is connected by hinge at its end and subjected to no external loading in between them, then it is termed as the internal link, and internal link carry the axial force only. Here, the QR is the link which carries only the axial force. Also, bending moment at Q is 0 and bending moment at R is 0. After that, we are going to see the different types of loading. The first type of loading is the point load. A point load is considered to be acting at a point. It is also called as the concentrated load. In actual practice, the point loads are distributed load which are distributed over the very small area. Second type is distributed load. Distributed loads are those loads which acts over some measurable area. Distributed loads are measured by the intensity of the loading per unit length along the beam. There are two types of distributed load. First one is a uniformly distributed load and other one is the uniformly varying load. Uniformly distributed loads. The uniformly distributed loads are those distributed loads which have the uniform intensity of the loading over the area. Then uniformly varying loads. Uniformly varying loads are commonly abbreviated as UVL, and it is the one in which the intensity of the loading varies from one end to the other end. For example, intensity is 0 at one end and W at the other end. Then next type of the loading is couple. A system of forces with the resultant moment but no resultant force is called as a couple. It is the statically equivalent to force times the offset distance. That's it for today's lecture.